I think we're ready for our first speaker. Ibrahim is here. Hello, Ibrahim. Tell me that your microphone works.
Yeah, hello. Can you hear me?
Hello.
Yeah.
All right. So Ibrahim's going to talk to us about PG routing and beyond. Feel free to share your screen. I'm looking forward to this. I'm a routing aficionado. Um, Over to you, Ibrahim.
Okay, you can see, I think, my also
I'm seeing
screen.
here.
Yeah, I'm Ibo. Everybody calls me Ibo. Maybe I will change my name to Ibo. Anyway, this is another subject. We can discuss it later. I'm going to talk about pgRouting and beyond, and also the other open source tools that we can use or you can use. I'm a geospatial developer. Actually, I'm a city and regional planner, but I choose coding on geography information system side. So worked maybe 10 years for a fleet tracking company. That's why I always tackle with this kind of problems on routing side. And now I'm working for a defense company in Turkey, and also we are facing some problems that we have to solve on routing side. So let's discuss what I've learned and what you can use on your applications, and what we have chosen as an application to on our code base, I can say. So I will talk about common uses of routing engines and prerequisites and advanced features and open source tools and some use cases and my findings. So let's start. Maybe you all know, yeah, basically network data, namely road data, are lines on an area. It can be a country, it can be a city level. And roads in GS are technically vectors. That means they're objects and they have to have some attributes. If they don't have any attributes, at least it has some length information, and you can just find the shortest path if you don't have any other kind of information of road network data. If you have this kind of attributes like speed limits and road types and direction data and the road usage information, you can calculate some costs. What is cost? Cost is going from one place to the other. It can be monetary cost. It can be time. It can be um, what you consume on the road as a fuel. So anyway, you define your cost. And speed limit is also very important here because each road segment should have a speed limit, and maybe road type is important because there are some um, limits on the roads, and directional data is important because there are lots of one-way streets and other stuff, and usage is also important, because there are some pedestrian ways and bicycle ways and you cannot go in with your car. So this kind of information creates a cost, and I will talk about the cost. So cost represents the weight assigned to travel along a specific segment of a road, and this could be measured in various ways, as I said, this could be time or this could be the fuel. Anyway, what's your cost is you define your cost. And you also has to have some algorithm to calculate this kind of cost. And there are lots of, uh, not lots of, but some algorithms that you can use, and there are lots of ready ones you can use. One of them is Dijkstra, I don't know the pronunciation, and A-star algorithm, and Bellman-Ford, and also bidirectional search. It works from multiple sites. And I'll not so much dive in this kind of algorithms because, yes, pgRouting just using it. Routing engines are using it, but I'm not going to dive in this kind of information. So maybe I will more dive in is advanced features. And to find a way from one point to the other, maybe you have to have some additional information like road type selection. You may have to prioritize or exclude some roads. And that means I don't want to pay to the roads in Turkey, to the paid roads. So I have to exclude these roads. When I'm also using Google Maps, I'm trying to do it if I don't want to pay for the roads. And also you may need some isochrone maps. And on the right side, you can see Melbourne map of isochrones in 1922. This is the I don't know this is the map of from the center to the periphery, the time-based polygons of reaching these kind of polygons, I think. And this is a very early version of isochrone map. And also there are some shortest path trees, there's not a polygon, but there are some branches of road network data you can see. And also area exclusion is so important because when I was working for fleet tracking, we were working with British Petroleum, and when they were carrying some stuff, they didn't want to go so near to the schools and other public places, so they wanted to exclude some places and also locations, not just places but also locations. And real-time traffic is important, for rerouting, recalculating the route, and also multimodal routing is important. And dynamic routing and multi-network data is also important for making this kind of solving routing problems. And maybe the most important is what I've faced many times is using your custom data. And so if you're traveling with a cat, it's okay. Just select 2 points and go from one place to the other. But if you're carrying this kind of thing, like a wind turbine blade, you have to choose some extra information from the network data, like there shouldn't be overpasses, there shouldn't be tunnels, and the road should be so wide to carry this kind of thing. So maybe you have to have your custom data. And there are some tools to use your data and also OpenStreetMap data, which are, I will deeply explain, pgRouting, GraphHopper, OCRM, and Valhalla. And what I want to say is, for voting engine, also one of the prerequisites is many of these tools create some kind of graph. This graph is a combination of nodes and edges. Nodes are for each point of interest and intersection. That means these are the connections of all road network data, and also the edges, that is the connections of the nodes. That means the roads. But the road is not as we understand in the real world. In routing, the road is the junction of 2 points, okay, from one street to the other. If there's a turn right or turn left point, that's a edge of us, I can say, and there's a node there. So what I'm talking about is custom data. If you have an OCM data downloaded from anywhere of like GeoFabric or VBike or anywhere, if you have OCM files, you don't need, and if you don't need any advanced features, that's perfect. Everything is fine. Just for Valhalla, for OCRM, and for GraphHopper, just run this start a Docker container, and voila, your RESTful routing service is ready. Of course, you have to download maybe continent data or maybe country level data from OpenStreetMap. And okay, you have a RESTful service. But let's talk about some pgRouting. pgRouting works different because it's a database extension. So you run an SQL and get the result as a list, and you probably need a backend service to consume this kind of result list. And so let's deep dive. pgRouting extends PostGIS and PostgreSQL. So there are some advantages for extending PostGIS and PostgreSQL. Data attributes can be modified, and data changes can be reflected instantaneously through the routing engine. This is so important, at least for traffic data. And the cost parameter can be dynamically calculated. This is also important because if you have your custom data, you have to calculate your cost yourself. And also OCM data can be used in pgRouting with OCM to pgRouting, and also you can also import your data, OCM data yourself with OGR to OGR, shape to PostGIS, or with QGIS. Anyway, so you have to not create a graph, but you have to create a topology in pgRouting. And this is some secrets that you can create. This SQL creates nodes and edges, and then you create your own cost. Here I wanted to explain length is also a cost. And also if you have a role type as an integer, you can use it. And if you have to have some reverse cost, that is for one-way streets, just use it. And voila, also here again, you have your own routing engine. But let's say it again, you have to have a backend tool. And so if you have 2 points and need a result as GeoJSON and find the nearest roads and find the road and trim, start and edge with the points provided, yes, not a perfect, but a usable solution is on my GitHub. My surname and name, Saricicek Ibrahim. You can find it on my repo as routing repo. And I have a PLPGSQL solution that you can see it. It gives a result as a GeoJSON and just you can consume it on any backend solution. So we want to use Grasshopper Valhalla OCRM with your custom data. What you have to do, there are some ways. There are some commercial to OCM tool for Grasshopper and also you can, as I said, use on pgRouting, but you can do there's a saying in Turkey, using your right hand for pulling your left ear, you can revert your custom data to OCM data. But we have to map some data, like we call streets sokak. So you have to map sokak to some data in OpenStreetMap. And you can find OpenStreetMap data on the wiki page, like there are ways like motorways and trunk and primary. What we map in Turkey is the all paved roads are motorways and intercity roads as trunk and blah, 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 blah. We are mapping this kind of data to OCM data. And then we can use Grasshopper, Valhalla, and OCRM. So let's talk about the advanced features again. Row type selection, yes. You can exclude or just use some kinds of data on OCM data by providing this data to the engines provided by OCRM and Grasshopper and Valhalla and also OCRM. Also on isochrome maps or shortest path trees, all support and with an external tool or API, but pgRouting solves the driving distance and plus SD convex solve if you want to create the polygons from the road network or from the road tree data. You can use pgRouting, and area exclusion is so important because I'm working for a defense company, and there are some zones that your weakest shouldn't arrive at that location. So on OCRM supported, yes, it's supported, but on creating graph. So if you create a graph, it's like an indexing. So if you're changing this kind of areas, you have to regraph again. It's not working on demand on OCRM side. But on Valhalla side, you can avoid some locations. Not a polygon, I think, as I is on my tests. I couldn't find a polygon, but you can avoid some location. On Grasshopper support, you can send your polygon on your post request. And on pgRouting side, it's perfect. Just select the route that touches or doesn't touch a polygon or polygons or a table, any special object, line, polygon, or point. So real-time traffic is also needed, and Grasshopper supports the traffic JSON, and Valhalla supports both historical and live traffic data. And OSRAM has experimental support. And on pgRouting side, as I said, you can create your cost values yourself. You can always update your data of cost, and you can create your traffic solution. And also multimodal routing, you can have multiple country data or multiple city data. As far as I know, no easy solution. Please do it yourself. And also on dynamic routing, recalculate routes in response to events and changes in network. So Grasshopper supports on API level, on OCM supports. OCM supports also on the graph side. I'm sorry, I didn't add more information here. And also multiple network data. I didn't test with Valhalla or OCRM, but on Grasshopper, just add your Maven dependency to your custom Java solution and you can handle multiple networks. That's perfect. And also on pgRouting side, just add a new table. That's much easy. And nearly all advanced features support and plus JS support. You can do it pgRouting, but pgRouting creates topology, not graph. Creation means a fast response, and for fast response, you have to do something else on pgRouting. You have to work on indexing and limiting areas, and also limiting the area of start and end bounding boxes, I can say. And you have to know about basic PostGIS and data manipulation and SQL and sometimes PLPG SQL. And there's no ready backend solution, sorry, but you can easily find lots of ready solutions on GitHub and also other applications. Plus, a database needs to be installed. And if you want to work on a desktop application, you don't want to install one more application like a database. But okay. So Grasshopper can be included as a dependency on your own Java application. That's perfect for desktop applications and better on advanced features uh, according to Valhalla law CRM. But I can say Valhalla has a Python binding and APIs can be used without an HTTP request service. And also generally, although similar results may come up, I can confidently say, I'm trusting my instincts, that OCRM creates roles that I would prefer to use in my real life, I can say. And that's all I can say. And to be honest, I can say yes, pgRouting solves maybe all my advanced feature problems that I face with. But the only problem is not that everybody, not all my customers want to use a database on their application site. That's why this may be a really problem, but the other stuff is always perfect for pgRouting site. Thanks for listening to me.
Well, thank you for coming, Ivo. So I have a few questions, as always.
Yeah.
Um, First around, the open source routing machine, OSRM. Remember that one? My impression was that, yeah, that I don't know, did you find it was a live project still? Was there still development ongoing? I thought that a lot of the development moved to Valhalla when Valhalla started. Was that it?
Yeah. Yeah. I see a blog post on 2011 or 18, yes, 2011 from Mapbox. And
Yeah,
they say that yes, they're using Valhalla for some of their customers.
right,
As I know, also on OCRM side, I see some contribution on also Mapbox side, and on Grasshopper side, there's a big company, and they also has open source solution. Also, you can have some paid solution
right.
on Grasshopper side. On pgRouting, it's all open source and.
Yeah. For PG routing, did you push it like with the size of the graph? That's the other thing in terms of limitations that I found with PG routing. And someone mentions here on the chat that in his case, like loading a whole country, all of Germany, makes things too slow for him. I was trying some larger sets. It's like, well, any ways
Yeah,
around that?
yeah. What I can say is if you want something like we want to get some result in milliseconds. Yes,
Mm,
speed routing has some problems, but in seconds, speed routing is okay. You know,
yeah,
but if you're in a war zone, and if you don't if you don't if you don't have in a rush, yes, maybe you can be in a rush, but if you all Turkey data from one side to the other side comes in seconds, maybe 2 or 3 seconds or something like that, but not in milliseconds.
right.
But as I said, if you want to exclude some points and polygons, and if you want to have to add some traffic data or other stuff, it's so easy to implement in PG routing.
Awesome. Um, you mentioned multimodal. Have you tried like transit routing or things like that?
Yes, yes. Yes, I said do it yourself because we're doing this kind of thing. Like yes, some products or stuff is getting transported with one vehicle, and then you have to change the vehicles. So we are doing this kind of thing, and this is not some multimodal, but these two vehicles use multiple graphs or road network data. That's why we are using our own model. And if we say that this is the stop point and don't use this graph or road network data from now here, and we will recalculate another route from another engine or another data. And that's why we are just mixing them up and creating a multimodal solution.
Neat. All right. Thank you very much for your time. Do we have, oh yeah, Kurt's already shown up here, but we're not going to start until it's time. Thank you so much for coming, Ibo. And I hope you'll stay with us for the rest of the day.